A m equals 0.1 kg bead is allowed to slide along a frictionless circular wire of radius equals 5 centimeters, as shown below. As the circular wire spins, the angle theta changes at a fixed angular velocity for the wire circle. The bead is also moving in a circle. Calculate the radius of that circle as a function of theta. Then calculate the angle velocity w required for theta equals 40. So we know this is a picture of what's pretty much happening. This is a circle it is, and this is pretty much where the bead is going towards of angle theta, and this shows out the radius of this is 5 centimeters, and we're trying to calculate the length of from here to here, right? So then this is a better image of what's happening. We're trying to calculate this side right over here, and then in order to find that radius out, it's simply just r sine theta. So the radius of this, if you change it to meters, will be 0.05 meters. So to simply, the radius of the circle that the bead is moving in is 0.05 sine theta. So now in order to find what w is when the angle is 40 degrees, is simply going to be square root of g tan theta over r. And we know this because we know that mg tan theta equals r w squared m, right? But now we could just do some math and solve for w, and that'll simply be just cross out the m's on both sides, and that would just be g tan theta over r equals w squared, and then we square root both sides, so it'll be w equals g tan theta over r. And we plug in the values, so g is 9.8, tan is, and the angle we know is 40, right? So it'll just be tan 40 over what r is, and we recalculate r over here, so we just take r here, and we know the angle is 40 degrees, so we put 40, and this will all simplify to 16 radians per second. So the radius of the circle that the bead is moving in will be 0.05 sine theta depending on the angle, and when the angle is 40 degrees, the angular velocity will be for the w and angular velocity will be 16 radians per second.